Good. Let's go ahead and get started. Welcome everyone. For some, it's nice to see you again.
But for some, it's not nice to see you.
I'm Joseph Baldwin with the Commission, and today we're here in Docket 1802517, Notice of Service Quality Related Technical Conferences, in which the Board requested 2 technical conferences, and this is the second one on advanced metering infrastructure. You can go ahead and do introduction.
Bob Davis with the Division of Public Utilities.
Cheryl Murray with the Office of Consumer Services.
Carol Ravel, Public Service Commission.
Autumn Braithwaite, Rocky Mountain Power, Customer Advocacy and Tariff Policy.
Allison Frazier, RMP, AMI Project, and the Workstream Lead for Customer Service.
Joelle Stewart, Rocky Mountain Power.
Mike Cochran, Rocky Mountain Power, Metering.
I'm Douglas Marks with Rocky Mountain Power.
Janice Sabat, Rocky Mountain Power.
Rohit Nair, Rocky Mountain Power.
Sherry Vance Commission.
Artie Powell with the division.
Brenda Salter with the Division.
Kate Bowman, Utah Clean Energy.
Sophie Hayes, Western Resource Advocates.
And no one on the phone, so take it away.
All right. Well, thank you. And Kate, please come up to the table. We're excited about this. I'm surprised that we was looking for an exciting turnout of people for AMI, but you'll get there.
You mean we're not?
Advanced metering.
Oh, really? You think that is like a? I don't know. Maybe I'm too geeky. That is like exciting to me. So we want to introduce you guys to our AMI project. We have AMI being rolled out in Oregon, California, and we're going to start Idaho this year. Those states, we do not have the AMR, drive-by technology that we currently have. And Douglas is going to walk through kind of the differences in in the technology. So in Utah, it's a little bit more unique than what we're doing in the other states. It's a little bit more complicated, and it's going to evolve a little bit more differently. And so we're going to walk through what the project is and then talk about kind of at a high level what our communication strategy, sort of the framework around it, as well as our experience in Oregon and California right now, since we are about halfway through the deployment in the meters there. We know we need to tweak the communications for the Utah project. As you'll see, it's quite a bit different, and there's different impacts on different customers. And then we will be needing to address some tariff changes or rule changes, and Autumn will touch on those. And so those are items that will continue to evolve. We are not going to be seeking any kind of deferral or accounting treatment for the AMI project itself. Just put that out there on the table, traditional rate making. We're going to put in the capital and recover that through a prudence review in a rate case. There is one piece that we are going to be using. We're going to be seeking step funds in order to kind of leverage, to develop some new technology to leverage some of the AMI across the current AMR system that will enable some new features for all of our customers in Utah. And Douglas will talk about that. And so that application will be subject to later discussion and possibly its own technical conference later, because we'll be making that sometime in the next couple of months as we put it together. So with that, I'm going to turn it over to Douglas, who is going to kind of touch base on where we currently stand with metering technology in Utah.
Okay. Right, so for those following along, we're going to go to slide 3. I'm going to talk about slide 3 and 4. So as many in the room will remember, back in the 2006-2000 timeframe, we filed to put what we call AMR, automated metering system, in the state of Utah, and that's a drive-by technology where you put the meter in, the meter actually puts a pulse out every 30 seconds, and that's kind of key. You put a pulse out every 30 seconds. You just drove by with the van, you pick up a pulse, and you'd have the meter reading for the month. It would drive by there once a month and capture those reads. So there were some significant savings with putting all that in back then. We started the actual project in 2008, built it out. We started with the Wasatch Front and Park City, Tooele, and then over the next couple of years we expanded it through the rest of the state. Now there were some limitations with that. There were certain meters that we could not read with the drive-by technology. So it was basically commercial and industrials that had like power factor billing, or if they required interval data, any of our meters that we installed for load research purposes, which was interval data, we couldn't read with this technology. So we continued to read those manually with our meter reading field staff. So when we came back and we looked at AMI, we knew we had this large population of these meters in there that put out that pulse data. And at the time we put it in, we envisioned putting sometime in the future, putting a communications umbrella over it that would listen to those pulses out of those meters. But the other thing the meter put out was an outage notification. So when it went out of power, it just put a single burst out, what we call a last gasp, that could be heard by the system. So we actually knew that if we put these meters in, that we weren't gonna just put them in and when AMI became time, we would tear them all out. That was our vision at the time. So you fast forward to now, we started looking at it, and we're looking at our cost for our customers and what we can provide. There was about when we started putting the business case together about 18 months ago, there was about 17,000 of the meters, commercial industrial, that we couldn't read with this system. Now, what's happened in the evolution since that time to today, as we got into the private generation tariffs with the interval data there, we put in about another 3,000 meters that are on interval data. So in reality, I got about 20,000 meters today on interval data. Well, we went out, we put an RFP out on the street, we went to all the major manufacturers and said, tell us what you can do. And so we started talking to Itron, and on page 4, we get a little bit of technology. I got ahead of myself. When you look at the technology of AMI, the FERC definition of AMI is just interval data available on a daily basis. It had nothing to do with two-way communications. It had nothing to do with connect-disconnect functions. It had nothing to do with all that. And so the predominant technology that started to evolve is they said, hold it, if you're going to put this communications out there for these smart meters, let's make it a two-way communication of the meter so you can enable all these other benefits. And so they ended up with a mesh network. And what a mesh is that the meters actually start to talk to each other, that if I'm a smart meter and I put out my signal, it may bounce to another meter, and eventually formulate through back to the takeout point, either an access point that then gets taken up on the cellular system back to the head end office. Well, what it did, the mesh network, is if I took out one of the meters, the other meters would work around it and still get the data signal back up. Okay, now you compare that to the current system, the AMR meters, they're just putting out a pulse, they can't hear anything else, so we have to put up a lot more devices on the pole just to hear these. So that's called a point-to-multipoint system. So we put a pole-mounted device that listens to several meters, so we put a lot of those up. So if you look at the diagram on the bottom right of slide 4, the point-to-multipoint system is located in the blue box at the top. The mesh system is kind of illustrated in the bottom of that blue box. So what we looked at doing here is we said, let's put the AMI out and come back and see what we can do. Well, the bids came back, and we're going to talk about the next phase. That we can put up this network umbrella, and to make sure that it's covering the whole state, we've got to look at a few other meters to get the mesh. You have a choice of either putting more pole devices up or changing out more meters to create the mesh. And you don't have to have every meter in the mesh, like I mentioned. You can have some. So that's kind of where we went. And I'm gonna come back to the importance of the difference between the mesh and the point-to-point in a minute. But what we looked at with the AMI system is what are all the functionalities that we can get out of it, or what are the potentials to use for it. So with the meters that are either smart meters, you'll hear smart meters, you'll hear AMI meters used interchangeably. People use it two-way meters, you'll hear that. Okay, so that's all interchangeable. What those meters started to give us was the ability to start looking at other possibilities. Those meters would have a connect-disconnect function in them. They would help us with load control because we're getting the direct interval data out of them. But in our vision for the future, what happened is this fixed network is still available out there, but it's not compatible with the two-way systems that they have today. Okay, and that's what we're going to talk about in the step funds here in a minute, is how can we get the rest of these meters in that. So what I'm gonna do is I'm gonna let Mike actually talk about the project and how we're gonna build it out. And this is gonna cover, you know, not the vast majority, it's gonna cover the entire state, but probably only about 20% of the meters in the state,
For the AMI portion.
for the AMI portion.
Right, thank you, Douglas. So we are going to construct an AMI field area network across Utah, and what that basically consists of is collection points. You referenced them earlier. They'll be pole mounted in most instances, and they talk to the meters, and the meters talk to that device. And the device can talk to a different number of meters, depends upon the geography and what the, where the meters are situated. And then once they collect that data from the meters, then it's backhauled via cellular back up to our head-end system for use there in storage in our MDM system, meter data management system. And then we can send commands basically the other direction to the meters as well. And we'll talk a little bit more about that when we get to benefits as far as being able to remotely connect and disconnect meters, receive outage pings from meters as they lose power, and be able to actually tell the status of a meter. We're going to integrate this AMI head-end software with our existing legacy systems, and what that means is we have a customer information system, a billing system that we will actually wire this thing up to, for lack of a better analogy, and we will connect it to our CADOPS outage management system as well, so that when we're receiving those last gasp messages, we can take them into our outage management system and make use of them. And then when we're working with the customer, say we need to reconnect service, and they're working in our CIS system and our billing system, then they can initiate an action either manually or it can be done automatically to reconnect service. So there's a number of different functions that will be able to use by actually connecting those systems.
Can you ask one clarification? So the third bullet says install 156,000 smart meters, and
Yeah.
you mentioned that. But that will ensure that everybody has the smart metering. They'll have the billing.
No.
No, it's only 20% of the meters.
So what we get here, the reason why we build out, we're talking 156,000, about 20,000 of those that we can't read today, that were mainly. But the others we talk about is you start to build out this mesh network. It's a trade-off, as I can put a whole lot of pole devices out to hear these few meters we put in, or I can start and go in and change out a few of the existing AMR meters to a smart meter to build out this mesh network, and it extends. And by doing that, for a lower cost, I can extend the network out wider by replacing meters rather than hanging a whole lot of pole devices to collect them. Does that make sense?
So, but
That's the interesting
But
thing.
the remaining 600,000 meters, you're gonna have to do those through time, or
Yeah.
and so how,
Let me step up to the step request if that works. I think this might answer.
Well, but I think just that basic question, yeah, I mean, absent the step request, we would then, well, even with the step request, we'd be rolling through, replacing meters, AMR meters as they fail with the AMI, but then we have the network in place that they'll be immediately functional.
Yeah.
and so it would be like many 10 years until the whole thing,
It'll be about
everybody
10
is.
years.
Yeah.
Okay,
Yeah.
thank you for that clarification.
Yeah, but then the step funds will actually help,
Accelerate
the technology that they want to develop with the step funds would, at least accelerate the functionality, provide some of the same functionalities, the AMI with the AMR.
Right.
How often do meters fail? Like
They-
the AMR?
It's about 0.3%.
Not often.
It's not very often. They last about 20 years.
And what was the depreciation like?
If I remember right, it was 20 years that we put in. What's actually in our schedule with meters, we do, and I'm not an accountant, so I don't know the word, but basically, we throw all the meters in, and these meters are good for 30 years, and these meters are good for 20 years. You just throw the whole population in the mix, and the average becomes 27. I think today we're at a 27-year average on the depreciation curve.
Yeah. And not only will we would put them in when they fail, but we'll put all new meters to be smart meters at the same time, so.
Yeah, so
We're
as
gaining
growth-
some ground there as well, our growth.
Yeah, the company has a testing program, right? They go through and test meters.
Right.
And so when they test a batch of meters, if that batch fails, then the whole batch is replaced, right?
Well, we do the sample test, And if we see a failure rate that's high, then we go to a more robust testing to
Okay,
sample it.
okay.
Did we just happen to randomly hit the bad meters in that whole batch, or is it indicative of the batch as a whole? We go to a stronger, more robust test the next year, and if that does show it, then we put a program in place to replace
The
it.
search and destroy,
What? Right,
Yeah.
okay.
Search and destroy.
as they call it.
Awesome.
So the idea is it's not necessarily one at a time. It could be groups of meters that are being replaced.
Yeah, and we have not seen that with the electronic meters like we used to see
Okay.
with the old electromechanicals.
Okay.
I don't remember historically, but the electromechanicals, like the pot coil would have a problem, and it'd be a batch because the varnish on all the wires and pot coils in that whole sequence of meters was
That's,
bad.
yeah, the serial number sequence.
But you're not seeing that with the electronics today.
Okay.
So, we still have a few, but it's not near the same level.
Okay.
Okay. The cost of the project, $70.8 million with a $4 million annual benefit. We're going to implement it over 2 years, 2 years and then completely finish it by the end of 2021. So primarily 19 and 20, and then it'll be wrapped up in 2021.
So what is the bulk of that benefit? Is that lack of drive-by?
It is, yeah, exactly. So to reduce labor associated with that.
And it's avoided new labor as we put in more and more interval meters that would have required manual.
The 20,000, you don't have to read.
Yeah, so like this year alone, we put in 3,000 new interval meters.
Right.
So you start to compound that year on year, it gets more and more.
So when you have the mesh network, how many uptake points do you have to have? Do you have one for all of Salt Lake Valley, or how far does the mesh network propagate?
So it depends. I don't know the real count. We have not done the detailed design. We've done the rough propagation studies that said, okay, with these points, change out these meters, we get coverage. But a meter transmits about 100 feet, maybe a little more depending on interference. Okay. So on the multiple point like we have today, I'm putting a lot of those devices up. But on the mesh, because the meters can hop and they can do multiple hops, it just all depends on the propagation and the interference in between them.
Yeah, they do software propagation modeling, and say, well, this is what we think it should look like, and then move into the real world, where we'll actually go out and do site surveys and see, what is there? Is cell service there? Is there a pole there? What is the geography there when you're standing there versus looking at a Google map? And then adjust, and then build it, and then even once we build it, we'll still have holes. So we'll go back through what's called an optimization process, where we'll look and see where do we have dead spots and what might we do to mitigate those. So generally, pretty good idea, and then as you go through, it becomes real.
Is this the company's own communication network, or using third-party ATT kind of stuff, or is it all in the meters, or how does that work?
So there's two levels of communication. One is the field area, which is from the access point down through the meters and back. And that's all based on the system we put in, so we own that, but it's licensed by Itron. And then from the access point back to our head end office, right now we're looking at a cellular, so we'll be using primarily Verizon in reality, and then that's just on a data charge.
Okay.
At some places, in some of the more remote areas, or where it's feasible, we may even jump onto our fiber optics in a substation if it makes sense.
So I think you mentioned, I'm sorry.
Thank you.
I think you mentioned, Doug, that we signed a contract with Itron to implement their reader system and reader meters. They're also designing the network for us and providing the meter hardware and the network hardware. We provide that I've actually been overseeing the Oregon-California AMI project for the last 2.5 years, and we're in I'm happy to say and shocked to say that we're in year 3 already, the final year of those projects. And we're just wrapping up California literally as I speak. They've gone, overall they've gone well. But I would be less than honest if I didn't say you undertake something like that and you've hit some bumps in the road and you've definitely learned some lessons along the way. And we have, and we've been keeping track of what those lessons learned are and keeping another detailed log of those so that we could use those going forward. And the opportunity to start doing that has presented itself now with Idaho and Utah. So I'm going to talk more about some of those lessons learned. I think a around communications today specifically. So we want to definitely make different mistakes than we've made in other places. And,
No, make no mistakes.
that'd be our goal, we'll make no mistakes. And do the things that went well again.
So are they doing a mesh like what you're proposing here?
Yes, we are.
Doing the same thing?
Yeah, it's a bit different, as Joel mentioned, because we don't have the AMR meters across either Oregon or California. We had some, but not nearly to the degree you have in Utah. So we're not putting in the exact same system. But the AMI piece that we're doing in Utah is a mesh, same exact concept as what we're putting in Oregon and California. And it's working quite well. We've been very pleased with the network performance. It's exceeded what we'd hoped. So that's been one of the good things about it.
Could you address the issue of the substantial increase in the amount of data that you collect on a daily basis, and whether you've had blips in managing that or accumulating that or saving that, or?
Yeah, that's a very good question. When you go from, say we have 600,000 meters roughly in Oregon. When you go from collecting 600,000 meter reads once a month times 12 months to a system that collects 24 reads a day, 365, the volume just goes through the ceiling quickly. We are only collecting total consumption at the meter, so we're not collecting any kind of appliance usage data or anything inside people's homes, although some people worry that we are, we're not. So we're collecting that.
And you can't.
We can't, that's right. And so, but regardless, we're collecting a ton of data. We're collecting an amazing amount of data around outage management, what's happening there. We've got meters that are calling us and saying, hey, I'm out of service, rather than a customer having to call us. And in some instances, those meters are calling us and because they might have a bad connection. So we're seeing some things that we haven't seen historically, which are actually good things. And we're bringing all that data into a meter, what's called a meter data management system, basically a computer warehouse, and storing it all. We have not had issues as far as billing is concerned. We're pulling all those reads in. We're making those interval usage reads, not so much the reads, but the consumption. In other words, what have people used by the hour available to customers? And Allison's going to walk through some of that here in a couple of slides. I'll show you, it's pretty cool, very cool.
Are you making assumptions in that data as to what appliances are running when?
We're not.
Do you intend to?
Not as of this moment, we don't. So, but we basically look at it, and she'll show you in detail what you can see as a customer. You can see what you're using by hour, basically, as of yesterday. So no issues around the billing data. We bring it in, we collect it, we use what's called a midnight read. We're still staying on a cycle billing, the 21 cycle billing plan. Our CIS system goes over and grabs a midnight read on the scheduled read date and uses it to bill, so we've had no issues with that. Having said that, we have a ton of data, and we're going to even get more and more data, and we have a lot of work to do, I think, around how do we use that data. And that's one of the things that our executives continue to push, that, we're spending money to get this stuff, and let's make sure we're getting business value out of it. So a lot of it's TBD, but the stuff that we need to be using right now for billing is working quite well.
And we're, the thing I'm excited about, this UI revenue module that we're putting in, that's gonna pull the data and make it much more user-friendly, that we'll be able to sort through interval or whatever we're uploading, hourly for residential, for my pricing group, and they'll be able to sort by different types of customers, and it gives us a lot more functionality in designing rates. So like in Oregon, no more load research data, we have all data. And it's just a tool that it just provides a much quicker ability to sort and use it, but it's still, well, I'm excited about all the data.
Yeah.
But it's just a matter of how do we make it usable, because it's raw.
Joel, that's what I was gonna ask, is if this increase in data in Oregon and California has had any impact yet on rate making?
Not yet, because it's still being rolled out, and so once we have like a full year of data, which we will next year, I imagine, in 2020, we can start using that for pricing programs. And so you know, on our current sort of rates case schedule, we're also looking at Oregon filing 2020, 2021, seeing what we can do with that data to kind of redesign rates in those states as well.
Will these smart meters handle bidirectional flow for?
The net metering customers or transitional customers? Yeah, they'll be used for replace the ones that we're currently installing. That's
Yeah.
part of the group that's getting the
I'm
AMI.
sorry, yeah. Actually, your question was, will they do bi-directional? They still do net. Okay.
So
Yeah.
you won't have consumption in bidirectional flow per hour?
Not gross consumption and not gross delivery, you'll just have the net between the two of them on an hourly basis.
And that's what the current ones, right now, it's not necessarily, it's 2 channels, but not, that nets it, right? It's
Yeah,
not.
it just nets out.
Okay, so I'm gonna move over to slide 6 and talk a little bit about project benefits. We touched on some of this. We see some huge opportunities to improve customer service. We have call center reps that are actually on the phone with customers in Oregon that are working to get their service restored, and their service actually comes on before the call is off, before the call is over. Now, that's not always the case, but we've had instances where that's happening, and that's a whole lot better than telling somebody will be there within 24 hours. And they say when, and you say, well, within 24 hours. Normally it's that day, but it's hard to pin down when it's gonna be that day because you're rolling a truck, et cetera, et cetera. Now it's just, typically a matter of minutes before we get that service restored. A huge benefit.
Oh, you mean after somebody like moves into a place and they want their power
Moves
on?
in, or has made a payment arrangement, or has made a payment if they were disconnected for non-payment, in any instance, yes. Same thing in the evenings, weekends now. If you call into our call center or go to an automated pay station and make a payment, that's all being wired backwards so that once we receive, the indicated that payment's been made, then our CIS system will automatically send down a reconnect order and have that service restored. So I think that's huge. Allison's going to show you again the web interface and how we're going to present to customers what they're actually purchasing on an hourly basis, which is a big change for our business. As you know today, as well as we do, we sell our product to people. They can't see it, certainly don't want to touch it, can't smell it, use it for a month, and then we send them a bill. And in many cases, they open the bill and say, there's no way this can't be right. I had no visibility into what I was purchasing, and I'm frustrated. And then they call us, and they call you, and it starts another interesting process, and typically they don't always end up very, very satisfied. So this system is going to allow them to actually see what they're purchasing, which I think is going to be a big benefit. It'll also allow our call center reps to, as they're interacting with customers on the phone, to see what the customers have been using. So rather than, have a discussion about what might have happened 2 weeks ago in a residence, and then oftentimes sending out for a manual reread, which in most cases is a waste of time because we have either AMR meters or very accurate meter readers. They'll be able to sit and have an educated discussion with the customer and say, what happened on Friday to Sunday in your home? Because we see your usage spiking, we see it spiking between these certain hours, and then you get into a realistic discussion about, I had a house full of company, or, you'll be able to zero in on specifically what's going on there, and I think that'll be a big thing for customers. Mentioned earlier that the meters call us when they lose power. Not everyone loses us as the mesh goes down, but some number of them will call us and say, hey, we're out of power. That alleviates the need for the customer to do it, or for the customer to sit and go, I won't call because I think my neighbor called. You sit there for half an hour and you go, I think my neighbor called. You look out, you go through that whole deal, and then you call, and in many cases now the meter will have called us. We'll already know that. It gives us a jump on getting restoration started, getting truck roll. And then we'll also implement some notifications back to you that, hey, we know your service is out, and here's the estimated restore time.
Does this give customers the ability to set alerts, triggers? Like on your cell phone, you can say, once my data hits something,
Yes.
let me know.
It absolutely does, and I'm gonna let Allison show you that. Rather than steal it from her. Okay. We're gonna take some vehicles off the road and reduce some CO2 emissions, which is never a bad thing. Again, I talked about outage reporting, and it provides us a platform for additional smart meter smart grid applications, things like DSM load control programs. Joel mentioned pricing options. We can look at various ways to do that. Distribution automation, et cetera, et cetera. So it really is foundational to implementing a whole bunch of pretty cool smart grid things into our business going forward.
If you're removing trucks and personnel, are these personnel being given opportunities to move to other areas in the
It's gonna be
company?
slide 9.
Okay.
Yeah.
You're gonna talk a little bit about security too, someplace?
Cybersecurity?
Yeah.
We certainly can. I don't think we have a slide on it, but we certainly can talk about that.
Are all these signals in the mesh network encrypted?
Yeah. And that's a lesson learned from not our Oregon, California project, but that's a lesson learned from us visiting other utilities who have implemented AMI systems over the previous 10 years when they didn't always encrypt.
Are the AMR signals encrypted?
I don't know the answer to that.
No, they're just on a proprietary knowledge, I guess, but they're not encrypted. You can build a device that can actually hear them if you can decipher what the coding is. That's all you have to do is just decipher the coding, but it's just straightforward. So, and there were several companies. I know Black & Decker got into the world a little bit. There was a couple other little companies that thought that with the AMR they could build a device, customers would buy that to watch their data, but most of those never really survive because it's an additional device in your house rather than being accessible through the internet or stuff. Okay. So with the AMI network installed, this lays the groundwork for future benefits. And the first one we really want to look into hard is, we've got one we're going to come to in the first quarter with the STEP funding for doing what it's called Advanced Resiliency Management System. It's just a big acronym that one of our engineers came up with. Okay, but it's really just a better outage management system so we can see what the system is. And there's two components to it. So one component we're going to be asking for is a little over $4 million for line sensors. And these line sensors we will put out on the distribution system so that we can get better data along the line for where the current flow is occurring at the time. Because right now what we know is what it is at the substation, and then we do a lot of computer engineering modeling to guess what it looks at on the rest of the system. So if we can put these line sensors along here, we can see what it's doing. We're pulling this down as a pilot installation for what we're calling critical facilities. Because what we see first, in the event of a major outage, there's certain facilities that we absolutely got to get back on power. If you remember those that were around for the tornado in 1999 that ripped through here, I mean, our first effort was to get the LDS hospital back on power because we knew about injuries and stuff and triage that had to occur. So you look at hospitals, you look at fire and police dispatch centers, other major trauma centers. So we're kind of just targeting distribution systems that target these critical facilities first as we pilot it out. It has no remote control at all. Okay, so we will not be using this system to disconnect and restore power through the distribution system at the beginning. We're using it as a monitoring technology. The other thing these line sensors do is when you do have an outage on the line, by the data coming back from those line sensors, we can determine where that's at, and we can shorten our patrol time. In other words, we can say, look, go to pole 24 on distribution 11. You don't need to start at the substation anymore to figure out where the outage is. We know where it's kind of starting. So patrol from there down and see what you can find out. The other thing that does is because we're getting the current flow in more places along the distribution system, we can quickly look and say, can I restore power from another circuit through the back door and isolate just a smaller section in the middle? Because right now, if we do that, we say, hey, we've got the wires down midsection in the middle of the line. An engineer has to sit down, pull out his models, and this doesn't happen very fast. Try to do the calculations and says, well, I think we're okay here. Can we get somebody out there to put an amp stick on it and check it? So now we can look at it and say, okay, we know we've got circuit B coming in here. We know that right before and for the last couple of weeks that there's enough capacity to restore power from there. Let's isolate the fault. Let's back restore power through here. We can get them on. So the whole goal here is just to shorten the outage time. quicker response, shorten the outage duration by getting more customers on faster. And so that's what these line sensors kind of do in there. Well, the other thing we looked at, we said, okay, we put the AMI system in, we've got about 150,000 meters covered that we can get outage management. What about all of these other meters that we've installed? The AMI system that we bought from Itron was not compatible with the old, what they called FM 2.0. Okay, FM 2.0 was the communications umbrella that would listen to all of my AMR meters that we looked at back in 2008 timeframe, 2007 to be exact, okay? So we went to Itron, we said, this doesn't work on Riva, what would it take to get those meters to work on the Riva system? And they said, well, for about $12 million, we can develop a device that will interface with the AMI system. It will listen to all of those AMR meters, compile that data, put it back onto the Riva system and bring it back. So by putting these devices in, I don't have to rebuild a redundant communication systems, the FM 2.0. I can use the AMI system that we're putting in as part of the metering project to get that data out. Now what happens is, because those meters have the last gasp in them, it's a different signal protocol than the AMI meters, so I have to translate that through to get it on the Riva system as well. So they're called power outage notifications, or PON. So when that PON pops up from the meter, it can get into what we're calling the ERP gateway mesh. It can get into that device, back onto my AMI system and come back in. So we've got to integrate that into the outage management piece. So that 12 million helps us get all of that data from the meters, integrates it into our outage management system, and it will also give us the interval data for all those AMR meters now that we didn't have before. This is why you said that meter puts a pulse out every 30 seconds with just, you know, the consumption data, and the devices will take that, put them all together for an hour's worth of 30-second stuff, and say, okay, here's a new read. Boom, now I've got my hourly interval data. So there's a side benefit to that from the meter reading standpoint. But we were looking at how can we get outage notification from the rest of our customers if we extend this. So that's kind of what the step funding request that we're looking at is going to do. It's going to help us improve the outage performance. Now there's
Just a quick question about that. Which bucket of funds are these coming out of?
I don't know what you want to call it, the 3. And so there's the bucket of funds, you're talking about both, we're putting both in. Yeah, so there's the bucket that's spread out, economic development, solar generation, battery storage, line extension, that bucket. We're looking more at the 3, which is the commission may authorize and establish funding for other new technology that's cost effective. And and we have, Rohit keeps calling it the USIP funds, so, and now it's stuck in my head, because when we initially put together the budgets and the amounts, we had put in there assumed full USIP use, and that has come way down, and so we're kind of looking at it as, because we have plenty of extra funds and stuff right now, but even with this, we'll probably be looking at a decrease. We have a couple more projects that we'll be filing for as well next quarter, but still might be ratcheting down the surcharge.
One quick question on that 12 million. Is that the price of just the interface, or is that actually getting some devices to make it functional?
It's the cost to develop the hardware that goes in the field to listen to those meters and build the software interfaces back into our system, into the outage management system, anything to make it fully functional.
But is there then additional cost to get each meter hooked up?
No, because those meters, the meters are already transmitting.
Right, the meters are transmitting.
So we just have to get the device on the pulse.
Okay, so the 12 is the total to functionalize all the existing
the remaining
AMRs.
Yeah, it's about 740,000 meters. Now, what's interesting, what kind of drove us to this is, so Berkeley National Labs has done studies for the last 20 years. What is the cost of an outage to the end user? And they've done it for every state, and you can go do it, and you can create a model and say, okay, here's how many customers I have, and here's the mix between commercial, residential, and industrial. And if I can decrease my SAIDI, say by 0.75%, what's that value to my customers? Now for us, our true cost of an outage don't really change a lot. I'm still dispatching the same crews. I've still got to do the same repairs. I still got to spend that on the infrastructure. But if I can shorten that time up by a couple of minutes, I think we did 3 minutes. There's a tremendous value to the end use customer on that. And so we were looking at that saying, if that can do that for our customers, that value to them, maybe we ought to look at a way to capture the rest of the meters in the system. So we put this big investment back in 2008. We were moving forward with AMI today, and we were looking at those meters saying, we don't really want to change those out. Let's let them run to end of life. And as they fail or through any other kind of program, we'll move through that. That's pretty good.
It definitely got attention.
I know who the shooters are in the audience.
So that's kind of how we were looking at this whole thing, because we see there's from a company standpoint, it's a limited benefit. You don't get rid of all of the vehicles for these existing meters, because we still have to manually disconnect them if we have to disconnect them or reconnect them. So unlike Oregon and California and Idaho, as Mike talked about, where we can get the reconnect really, really quick, we can only do that with the AMI meters. We can't do that with the AMR meters. So I'm still gonna have to dispatch somebody out to go actually do that reconnection. So, and over time, that will slowly change as those meters get replaced. But we don't get a lot of reduction in field staff for that portion of the meters.
We can still present that interval usage data to customers.
We can still get the interval data,
Get the outage information.
and we can get the outage information. So two big benefits to the customer, I think, in that one time.
While we let the AMR meters live out their lives.
Yeah, in peace.
Is the outage information the last gasp you were talking about? Is there any specific information about the conditions on the system, or is it just kind of a ping that the power's gone out?
Yeah, that's all it is. It's a ping. The meter just says, I'm out. And it'll put a ping for any reason. So we go do a disconnect, it's gonna put a ping out because we disconnected. So inside our information systems, we are building stuff to say, is there a work order associated with this site? Is there any reason there might be some outage here? And the other thing I did fail to mention is when the meter goes back in and power comes back on and the network can hear it, it'll send us a notice that says, I'm back on power. Now the difference between the AMI meters or the smart meters and these AMR meters is in the AMI world, I can send a ping out to say, can you hear me? And it can answer back. These AMRs, we send a ping out, it doesn't know it. So all we can do is just, if we can capture that restoration notice, that's great. But other than that, you're just kind of watching, and then you can go out and you can poll the system and you say, give me the meter reading data, and you can see, is there a change in the usage at that house in the last hour? That tells me that they're back on and using energy. And I mean, a simple 1 kilowatt hour change would tell me that they have been restored. So in very remote areas, we can use that technology to make sure we don't have nested outages and have to re-dispatch crews to fix them.
Yeah.
So there's some benefits there, but again, it's shortening that outage for the customer that helps it.
Because nested outages are a problem, because the customer thinks we know they're out of power, we think they're in power, and everyone just sits. And it's not a good situation, so we want to look for ways to eliminate that, so we actually know what is the real status there. We don't assume that just because you're on a feeder and we got the feeder restored, that you're restored, because you might be sitting behind a fuse with 6 neighbors that are still out for a more localized condition, so.
And you'll recall the winter snowstorm of 2003. That was one of the biggest problems we faced, was finding those nested outages.
Yeah, and then you're sitting in your house and watching the line truck drive away, and you're still out of power. That's frustrating. And we think you're in power, so.
So the AMR meters cannot communicate with the AMI meters?
Correct.
So they can't join the mesh network?
No.
So for $12 million, how many AMR meters can you replace with AMI meters?
So
So rather than spend the $12 million, why not apply that to new AMI?
To replace those remaining 764,000 meters with AMI meters and with the resulting CGR devices to read them, you're looking at somewhere between 75 and 100 million.
And then the stranded cost on top of that.
Right.
The stranded cost of the 700 meters that are left. So that, I mean, these AMI networks, the AMI meters themselves are very expensive. So that's why we kind of tried to limit them in comparison to the AMR meter. So that's why we looked at that. We thought that was a pretty good thing. And then to Carol's, about the AMR meters, they've got about 10, 12 years of life left in them. And slowly over time they'll get replaced and we'll rebuild the network over time. So instead of a big capital burst now, we can spread that capital out over many years.
So your total project cost on page 5 is 7.8 million.
70.
I mean 70.8, 7.8, that would be pretty good, right? Yeah. And does that include the 16.5? Okay, so that is the AMI meter portion. This is the fix the AMR problem portion, okay?
Yeah.
And when you file, will you put in there something about what the annual O&M and all of that might be for
Yeah.
this?
We'll finalize that all out.
Yeah, we gotta work through the details of what that final looks like. I mean, yeah, if you have things in there in particular you wanna make sure we hit head on, let us know.
On the advanced line sensor technology, is that similar to, the transmission system they put on those really high speed sensors as,
The traveling wave sensors.
yeah, the ones that got funded during the era for, it was super high speed and you could get, is that what you're talking about here, or is it something different?
It's a lot different. It's basically just putting trying to think how to put this. It's really just a current flow sensor that has communications capability out there on the line, plus it has the ability to say, I saw a fault go through me. So it can pick up that and then send that data back. So it's not like, they're called traveling wave sensors on the transmission systems. Those are very high speed waveform capture devices.
Right.
Yeah, it's not that same level, that's that technology. As I watched the system build out over my career, basically what you see technologies get developed on transmission, and then we slowly bring them down into distribution. That technology is not ready for distribution yet. But if it was, you would put that at the distribution substation first, and then you would start to work your way out through the line. So we're looking at putting this just simple line devices out there so we can see the current flow, and when we see any indication of a fault, so we can dispatch the crews to the problematic area earlier and faster than we would have been able to before. Now, there's a device out there called a communicating faulted circuit indicator. You've probably heard of those, I don't know.
Oh, yeah. Just yesterday.
So that functionality is in these line sensors, so it's not, we don't need a separate device for that. So we get current measurements, current flow, and we get fault indication.
Do they provide any kind of system reliability, like frequency or voltage?
No, they're just a monitor. All they do is monitor. Yeah, so it's not like a capacitor that would help you with voltage.
So you wouldn't be able to determine along your distribution feeder where you had problems with frequency or voltage or anything like that?
So we've never measured frequency at the distribution level. The voltage, that's a great point, it's a good question. The voltage will get that, the AMI meters will tell me voltage. The AMR meters will not. So by completing this mesh with the 20% of the meters being replaced to complete the mesh, I do get bellwether meters out there on my system that can help me identify voltage issues, but I may not get into line voltage because there may not be a meter there.
Yeah, the voltage data goes back to your question about the data in general. What are you going to do with it? And we've got engineers just chomping at the bit. We want that engineering data yesterday. So.
And just a couple of points to add. So one thing on the transmission piece. So the transmission ones are really sophisticated because with just one device you can just pinpoint the location. But with these devices, you'll have to put multiple devices because The distribution system is much more complicated. So what it does is, like Douglas mentioned, it sends out a signal saying that, okay, it's like a fire alarm, saying that, hey, I'm out, and the next device would send out a signal, so you know the fault is between these two devices. So, and what also helps to your question is, when we run an analytics later on, we can figure out, okay, we are having a lot of issues between this section and this section, so let's focus more in this particular area. So it really helps both ways.
See, the engineers are excited. This is pricing, everybody's excited.
As excited as you ever seen it.
So that's kind of our first shot, is saying, look, let's leverage this AMI technology and see what kind of benefits we can bring to our customers with it. And that's kind of our first place of stepping into.
I have one more question about the AMR meters that would sort of be upgraded. You mentioned that, not physically upgraded, but get increased capabilities through this. That customers could have hourly interval data. What does that look like to the customer? Do they get it real time?
That we're coming to that.
Okay, got it.
Yeah, it's the day after, just
So, just one other question. So, we get annual service quality reports, so how will this, and you mentioned SADI, hopefully, so how will this evolve over time? How long will it take before we start seeing improvements in those reports? Do you think that?
Well, those reports cover the whole system.
Right.
Yeah, so it'll be several years before you see that, because we're putting a pilot in here, so we'll be watching those circuits specifically to see what have we done on those circuits specifically. And then when we start to roll it out further into the future, we start looking at, okay, let's go ahead, other critical areas, let's go ahead, our worst performing circuits, let's get those beefed up. You know, we do a lot of system hardening,
Right.
you know, today, but it's really done on a very thought out, educated guess. I mean, it really is, it's a swag. Where in this, you're gonna have, once you put these out, you'll have better data, like Rohit mentioned. Okay, we're seeing out in just this section of line, this is where the biggest problem is. It's just not hearsay from the lineman and saying, oh yeah, that area is always a problem. So.
I know that Oregon and California are different because they didn't have the AMR technology, but have you seen improvements in the reliability measures?
It's too early to say that,
Quality measures,
but I will say this, we're seeing some very interesting information coming back from the meters that we have not had in the past. Some information that we suspect is around power quality. So indications are that it's going to provide us valuable information, and we are actually using the information in the areas where we've already implemented, which is about half the state of Oregon and all of our customers in California, which are not a lot, it's just 47,000.
Right.
But we are actually taking outage calls from those customers, or from those meters, and actually rolling trucks with them and using the data. But we can't show you today that here's a measurable improvement as a result of that. We certainly expect to.
So back to my other question, these advanced line sensors that you're gonna deploy on the system, I'm just thinking about the other step project where you're putting battery storage on the end of the distribution feeder to resolve some of those issues. Is there an additional cost or a small fractional cost that would provide you any of these metrics on the distribution line that may be of value for distribution planning in the future? I mean, is this an opportunity, if you're gonna go roll these devices out now, to collect some of that data? And I think too, also the additional electric vehicles or IEEE 1547 is a factor. So is this an opportunity to spend a little more to provide information?
So the answer to the last question is yes. We get more information out of them. But it's not targeted the same thing like we targeted with the Penguins project.
Right.
It's not targeted the same kind of solution. So right now what we're looking at primarily here is to hit the outage management. We can get some more engineering data to help us with the reliability aspects of the system. So that's why we went with the terminology resiliency.
Right. I just wondered if you pay an extra 30 cents, do you get a sensor that tells you more things?
Oh,
Yeah, so we'll be looking at some sensors that will also be providing us reverse power flow information, possibly. And, you know, it will provide us information on voltages and things like that. So you brought up IEEE 1547. So that is one of the reasonings behind that standard, that they want to fix all the issues at the customer level itself, because the moment the utility starts deploying technologies, it gets way more expensive compared to a customer responding to some of the issues itself. So some of the sensors, we will be able to leverage some of the capabilities to look into those kind of informations.
Kind of see where you might have some issues.
Absolutely.
And that's why we want to do it as a pilot, just
Sure.
a limited number to see what we can do with it and what it does. Because we're basing it on some pretty good research, but you're also basing it on the salesman. You know, and you don't always get everything they say unless you spend a whole lot of other money to get the additional information. So we're gonna have to analyze that as it comes out.
Okay, so slide 8, just a high-level overview of the timeline of the project. We touched earlier on IT integration with existing legacy systems. That's the first row. That's underway now. We'll go through 2019. We are just in the very early stages of meter qualification testing. We look at all the various meter programs and the meters, make sure everything will work as designed. We move out.
And the security right now.
What's that?
This right now is when we're working on the security issues you talked about.
Yeah.
We're making sure all of the cybersecurity issues are addressed up front, so as the system starts to roll out, we're already protected and fully compliant with the NIST standards. I know how to spell that, but I don't know exactly what it means. So we have really smart guys that do that, but that's part of what we're doing right now.
Exactly. And then you can see that we're going to move into the more serious phase of the network design and construction in the latter part of 19. Meter installations in 2020, first 3 quarters of 2020. And then extend the AMI networks out to the remaining AMR meters through mid-21, and then customer communications will start in mid-19 and run out to the end. And Alice is going to talk about that in a lot more detail with some examples of what we've done in Oregon and California.
Optimization of the network.
Yeah, and I mentioned earlier that we have to optimize the network on the point. So we look at it, we see it's performing, what percentage of the meters are we talking to, why aren't we talking, where do we have dead spots? It's a cleanup activity, if you will, so that also happens in the 2021 timeframe, first part of 2021.
So when you're doing your meter installations during that time period, would there be any area that's completely replaced? Or is it all areas are just gonna have to wait till the other meters get replaced on their natural life cycle? I mean, is there like, we're gonna do some, like Cedar City or something like that, yeah, right?
Yeah, so the answer is, we've been looking at the propagation studies right now, and it's an economic consideration too. So one of the places that most likely right now that I'm looking at that we'll just replace every meter in there is Bryan Head Resort. Okay, because
All
you've got
3 of them?
Sorry. There's 12, that's why we're. So what happens up there is, because of the geographics of those canyons and the trees, the pines are big interferers to signals. Up there, we would have to hang a whole lot of access points to get the network through that canyon. So we started looking at it, and it's better to replace the meters to let the meters extend the network down through the canyon. That's just a small example. There's kind of a trade-off when you start looking at it. So there's no targeted area that we said, we're changing out 100 meters. We will only change them all out if the propagation study says it's more economical to do that than to hang additional pole devices, because the pole devices are expensive.
Sorry, what was the distance, what was the range for the meter-to-meter communication?
The reliability, I think I said 100 feet before, it's 100 yards. I misspoke that. It's about 100 yards for absolute connectivity. I mean, today, we were here in Midville, we were reading meters out there on the top of Kennecott. So, a lot of it has to do with the conditions, but when you do your studies, you base it on what you know. And of course, when you go build it, as Mike said, getting off the Google Maps, start to build it, you start to find either holes, or you find out that you can actually extend a little further. So I mean, it's both cases, so.
But this is the range that's
That's the
counted on.
that's the rough range.
We've actually
Just about
found
any
areas
condition.
in Oregon where the system's performing better than we anticipated. We thought there was a general lack of cell coverage. It's reaching it further than we thought it would, so.
Yeah, cell coverage is one piece of it. That's good.
So the next slide touches on employee impacts. The bulk of the employee reductions will occur in 2021 as we get out to the end of this. We have notified the employees that this is happening. We made a commitment to them some time ago, I want to say 10 years ago, if not longer, that we would be upfront with them as soon as we made a decision on AMI. And so we've done that. One of the first things we did after receiving project approval was to meet with all the employees and let them know that the project has been approved and we're moving ahead with it, so that they have time. I mean, that introduces challenges to us to run a business when you do that, because people start to immediately look for other jobs. They start to stress out about their job and their mortgage payment, and their family, and all the things that go with something like this. But we really believe strongly that that's the right thing to do.
So they all apply to the federal government, right?
And I don't hear that's not going real well this week. We'll see.
How many employees do you think,
23, I believe, is the number in Utah. 23 reductions in Utah.
And that's the number we used when we did the analysis. As we started to look at it, that may go up or down a little
But it
bit.
gives you a pretty good idea. It's not 200. Exactly, not 200.
Just for reference, when we did AMR back in 2008, it was over 100 employees.
Yeah, just over 100, 103. So there will be opportunities to bid on other positions, as there are today. One of the advantages I see in this particular area is that it's a pretty big area. There's a lot going on here. We have a fairly large call center here, so we'll see some movement from some of these folks into our call center. We struggled with that in Oregon, especially, and we will in parts of Utah as well, where you get into more rural areas and you don't have the job opportunities. You can't just drive to the other side of town to go to a call center, right, instead of a different location. So we do want to do whatever we can for employees. We're not going to go out and create other positions for them just for the sake of keeping them employed. We don't think that's in the best interest of our customers, frankly, to do that. But we will help them where we can. We're going to provide some resume writing and interview skills training in Oregon, and I need to look into this in Utah. I'm sure you have this here as well. There's some government agencies that can come in and help with retraining and networking opportunities. We've done some of that, especially the southern part of Oregon, so we're going to look at opportunities to do that as well. And just generally look for ways to support them. Some other things we've done is we have jobs that post internally every day in our business, and we have set up in Oregon, and we'll do that here as well, a process where employees can get notifications of those job openings at their home email address, so that they can watch that more closely. Because oftentimes they'll be gone, they'll be sick, they'll be on vacation, they'll miss a job opportunity. That way they can see it. And we've also instituted a program where we have our hiring managers offering interviews to these people, assuming they meet basic skill requirements, right? So if they're a meter reader that wants to be an electrical engineer with no training, no background, they're not going to get interviewed. But if they're a meter reader that, could be a business analyst or is interested in being a business analyst, we're making sure that they at least get in front of that hiring supervisor for an interview. We're not promising them the job, but we're making sure that they at least get that opportunity to get in front of the hiring supervisor. And I can say this, it's a high priority to us too, and it's come down from our CEO, that we want to do everything we can for employees so that when, the music ends, people that left, I struggle a bit to say they wanted to leave, but they found opportunities on their own, or they found other opportunities within our business, that they weren't just standing there with no chair to sit in. We want to do everything we can to minimize the number of people that find themselves in that position.
In the Oregon case, how many employees were they?
100, right at 100. Yeah, and then about 7.5, I want to say, in California. So.
7.5 employees.
So we also have 47,000 customers. Seven and a quarter.
He didn't work very hard.
Somebody who shows up physically.
Yeah.
You know about that, Bob?
I know about that.
You don't have that here, do you?
Well, maybe.
Okay, Allison, we've been waiting patiently.
have been.
Communication, good job.
Yeah.
You're up.
Okay, so as Mike said, I'm going to talk about communication strategy, and feels like many moons ago before we started Oregon. I mean, people have been working on Oregon and California for like, it's been many moons, but many moons ago, we sat down and came up with a communication strategy because we realized that, you know, communicating change to customers, everybody knows, you know, change is difficult at times, and so whether it's just a meter, it can be a lot more difficult than what you might perceive. So, and then we had some great benefits, so we wanted to make sure that we created a really good communication strategy for our customers, and we wanted to get out front and let them know what was going on. So we created what we consider these 4 key components, you might say, of this communication strategy. And, you know, it was around awareness, education, acceptance, and big picture. So awareness, we really wanted to have them know what to expect, you know, just what's going to happen, you know, whether it's our customers or our stakeholders like you, just what's the project about, what's going to happen, what's the impact to you, what's going to be the benefit to you, and certainly the biggest focus is going to be on benefit to them. Education, you know, that's part of it too. How do they work? What are the benefits they provide? And for this scenario with Utah, we've got, you know, a mixture of AMI and AMR. So it's going to be a little bit of a different communication strategy that we're going to have to take, because I may have a neighbor who has AMI and the next door neighbor may have AMR. And how do we communicate those differences? And how do we communicate the benefits to them? So we're still formulating that, you know, taking what we've done in Oregon, and I'll show that on the next page, but also how are we going to translate that so it's clear and concise, it's not confusing. And primarily I will say, we're going to focus mostly on benefits to them. We're going to really hone in on what, you know, this new features are going to come about with your meter. What's going to happen to you if you have an AMR meter, but, you know, there's these great things that you're going to get now. So we're still working through that, but, you know, we'll let you know, definitely what we've come up with. Acceptance, addressing any concerns, that's a big one. You know, we have found that through lessons learned in Oregon and California. We have some customers who are not accepting of an AMI meter. And so we have definitely not ignored those concerns. We have, through lessons learned, realized that it's important for us in certain communities to get out in front of that, to hold workshops. And we have a group of about 7 of us. We set up a workshop. We have different stations that provides them information on the meter. What does that look like? If they have concerns about RF, if they have concerns about privacy. We also show them, you know, what they're going to get out of it. So what they're going to see on the website, and you'll see that in some follow-on slides. Some energy efficiency tools. So we really try to partner with that community and come down to their level and have honest, open conversations. So they don't feel like we're just imposing this on them. And so it's been a very effective tool in Oregon to hold those community workshops. And again, we'll address that and decide whether that works with, you know, these communities. Because again, it's a little bit of a different, you know, shift here. It's not just full sale replacement, so.
And does Oregon have an opt-out?
They do. They absolutely do.
With a charge?
Yes, we do, yeah. And, you know, that has created some, you know, consternation, being completely honest. Of course it is, you know, people, you know, have concerns about that, whether they're low income. And so we've been definitely trying to address that. And as Mike said, we set up, you know, we have a call center, everybody knows that, and we set up a separate group, just purely AMI. And we've trained them extensively on it. They are an amazing group of agents who know the technology well, who know the states and the rules around that well, and have done an amazing job of walking through people who have questions, who have concerns. And that same group is going to be here for all of the Utah customers. And they're going to be well trained, and they're going to be well versed so that they can sit and provide those answers to whatever question comes up. So that's really important, addressing concerns, you know. Change, like I said, can be hard even if it's a leader. People just really react to that. So we want to make sure that they feel like we're listening. That's our key thing, we are listening. And big picture, of course, you know, we have a lot of people who are very engaged in EV, engaged in smart grid, and we want to make sure that we also paint that picture, that we are, as a company, moving in a direction that technology is moving, that, you know, we understand, like we're taking cars off the road, that we are engaged also in the big picture, and that we're moving towards that, so that you'll see communications in that. You know, we have on our website right now for our Oregon and Utah customers, we have a host smart meter page dedicated to that. We have videos out there.
Oregon and California.
Oregon, California. So, sorry, not Washington. Yeah. I got a Washington question. That's right. On AMI, sorry. You know, we have a whole website dedicated to that. We have videos out there that explain, you know, kind of big picture, what it is we're doing. We will be looking at that. We have a corporate comms group that is amazing, has, you know, has helped come up with this communication strategy, really driven it, and, you know, we'll be looking at Utah's own page. They'll be able to really, you know, customers should be able to go out and see from a benefits standpoint what these meters will bring them. And again, we'll realizing the demographics of what we're doing here, we'll make sure that we don't make it confusing, the AMI versus AMR. So we, you know, that's definitely in the back of our mind and making sure that we always address that. So next page, installation communication. So this is very small, sorry about that, but we created kind of a logo for our smart meter project, and we will carry that same logo into Utah. And what you see is, what we're aiming for is a little meter there, and you've got 2 lines coming to that meter, and it was really meant to be kind of a synergy. It was meant to say the customer and us bridging that meter together to create a benefit for you. And so just as a high level for Oregon, California, we took a very similar tactic. We sent them a postcard about 40 days in advance saying, hey, we're coming out to your area, we're gonna be installing these meters. Go to the website if you've got any questions, call our call center, you know, very open and honest. And then we, about 45 days, 30 days ahead of that, we sent them a letter, said we're gonna be in your area, we're gonna be installing it. Again, you have a right to not accept this. You know, if there's a number, please call if you've got any questions. Once we get about 2 weeks out from an install, we would place a phone call. And we would say to them again, you know, we're gonna be in your area, if you've got any questions, give us a call. And really, we wanted them to have the phone calls so that they could understand, you know, maybe I've got stuff around my meter, I need to clean it up, I've got a dog, you know, whatever it is. And if they want to call in and make an appointment, we're accepting of that too. So again, we've been trying to be very, you know, work with them every step of the way. When we have installers out there, we have a door hanger that says we were either successful if we were able to do it, and it provides them a bunch of information on that. On the meter again, and future benefits. We also have a door hanger that if we weren't able to do it, that basically gives them a number, says please call, we'll schedule an appointment. We definitely want to, you know, get this accomplished. And we do knock on the door before we even install. People may be in there working on their computers. We don't want to just shut off that power and have them come running out the door, you know, upset with us. We want to, again, very respectful of you know, what they're doing. So,
how long does it take to install a meter? About?
Yeah, it's pretty quick.
5 to 30 seconds maybe.
Yeah.
What's your
Yeah.
meter base?
Okay.
Depends on how big the dog is.
Yeah. How fast you run. Yeah.
How long was it, sorry?
5 to 10 minutes, maybe 10 minutes on the outside probably.
But how much time, like, one time,
How much time is the
one of our
actual
other
power
things,
on?
if you pull it and put the new one in, could it be 20 seconds you're without power? or-
It could be, yeah, it could be as short as that. I mean, we pull them out, we do a tension test on the jaws, we usually inspect it quickly to make sure there's nothing unsafe in there. Because some of these meter bases are old,
Yeah.
and so you might see something that's concerning. And if we do, we might not want to put it back in.
Right,
In which case, we'll have electricians on call, and we'll call them and get them over within a couple hours, tell the customer, of course, and pay for it, we'll pay for it.
Yeah.
To get that corrected, but typically it's pull the meter, it's walk up, photograph the meter, to take some pre-install photographs, clip a seal, pull off the ring, pull out the meter, put in the new meter, seal it, photograph it, you're done. So it could be just moments.
So then as a
Typically,
follow-on, yes, sorry, Mike.
Sorry, just
As a
typically.
follow-on, you know, we have some test period about 30 days where we collect not only our new AMI reads, but we haven't converted them over to billing, because we want to make sure that we've got, you know, that we're falling in line with what we had seen before, so it's kind of a test period. But usually within about 30 days, we then convert them over to pure AMI, to AMI billing, to AMI reading, and so then we send them a postcard, and the greatest thing about that is this data then becomes visible to them on the website. So at this point, they can start tracking their data. And so again, we follow up with a postcard letting them know when that has been done. And, you know, like I said, again, we'll be very cognizant of how we roll out this communication plan for Utah.
So they can start to look at data that is from yesterday, up through yesterday, on the web.
Yep. So if you'll,
So is that true for the AMR that are coming in, or is that only for the MI?
It will be true for the AMR if we get the gateway meshes put in. They'll get the interval data as well. That's why we want to develop that
Right,
interface. We think it's a little more important, for neighbors to all say, oh yeah, I looked at my data, versus the guy goes, hold it, you got data and I don't?
They're gonna call and ask for the meter.
Yeah, exactly, that's the problem I see. It's gonna go
Yeah,
both
what
ways.
is
I
that
don't
phone?
want it and I do want it.
right,
Yeah.
exactly.
1-800.
An opt-in charge?
Yes, yeah.
Yeah. Yes. So again, yeah, very, very cool. It's gonna be awesome because there won't be really to any customer, there shouldn't be that delineation between what I have and what you have. Because we're gonna be able to grab all that data and be able to present it on the website. So if a customer has been converted over, you might say to AMI billing, now AMR billing, they're gonna log in, and what I've got here is kind of like the first little to the left is really when they come into their account. It basically lets them see, you know, current bill, and then that's where they start seeing their usage. And they're like, okay, yeah, this is not just a 30-day, you know, month. I all of a sudden can start really seeing a day-to-day usage there. And, you know, we also pulled up average temperature. So if I'm a customer and I come in and I go, wow, I do not know why I got this bill. So I hop on and I look at that and I go, oh, that's interesting. Well, I can see the temperature. It really dropped that day. But if I want even more granularity, you can see right next to there's a usage calculator and there's a usage details. They can click on that, and that will actually take you to the next slide, but I'm gonna hold on that. So that's the next page, but hold on that real quick. So to the left of that, under that your usage, there's a little in blue, it's called projected bill. So what we have done is we have created the ability to, based on past usage, to basically kind of project out for the customer, you know, how they've done in the first 7 days of their billing cycle, what we project. If they don't change their pattern, this is what we project your bill is going to be. So that says to the customer, oh, okay, I'm concerned or I'm not concerned. So if they click on that, they can actually go over to this Your Alerts page, and it's also on the left-hand nav when they move over. You can kind of see, we set up this Your Alerts, that it's down under projected bill. You can say, hey, not only do I want billing notice coming to me via email and text, but I want a projected bill to basically send me a text that says, if I hit over this 170 based on this projected bill I might have over here, I want you to send me a text. And after the first 7 days, it starts sending you a text, you know, basically once a week that says you're on target or you're projected to be over target.
For people who do average billing, will it project that out too and say, you know, at the end of your annual billing cycle, your bill's gonna change this much? Will it do that?
No, it's not a bad idea though, actually.
That's a
I've
great
never
idea.
actually heard anybody suggest that. You don't project what your monthly bill is, but I see what you're saying. It's like, am I digging a hole here?
Yeah.
I know
Right.
$1,000 at the end of my catch-up month.
Yeah.
It doesn't, but that's,
No,
we
but
should
that is
make
a
a note,
great
that's a
idea.
good idea.
Yeah, thank you.
I'm
Yeah.
glad you came to the table.
Yeah. So, yeah, so that's really been a really great benefit that we've offered to them, and we have a lot of customers who signed up for that, because again, this goes back to what we stated as a benefit to our customers is we want to help you manage your power. We want to help you manage your bill. We've got a lot of people who, whether they're working, I mean, it's just, myself, I mean, just like everybody wants to manage that bill, so this really is a feature for us to help you manage that bill. So if you want to turn to the next page, this is really, when you hit that manage usage, at the bottom, you can see that you can select all these different views. You can select day, you can select week, you can select month, 1 and 2 years. But if you focus on the day, it really takes you on an hour-by-hour basis that shows you where you're hitting your peaks based on this, the data that we're collecting. So you can kind of look at and go, well, I can see when I'm getting up in the morning, I've got this 6 a.m., 7 a.m. kind of spike. And then, I can see maybe we're coming home at 5 o'clock and I've got usage that's gone up. I've started the laundry, I've started, if you've got an all-electric house, you can definitely see where your usage patterns are going up and down. So we've had customers who've said, yeah, I didn't even realize that I've left the air conditioning on all day long, the impact that had. I decided the next time to turn it down, and I go out there and look, and I'm like, oh, wow, I've really seen it trend down. So the great thing about this too is we created for our agents basically a kind of an area, a portal for them to go in, and they can see exactly what the customer's seeing. So if I am a customer and I'm calling up and I'm saying, I don't understand this, or I don't understand what I need to do, the agents can walk them through step by step as if they're looking at their website. So it's been a great benefit for our agents to also help customers kind of notice their usage, kind of point out maybe, do you have a plug-in heater, just try to drive them to what might be making these, spikes go up and down.
I had a customer tell me the other day, and I never thought about this, they use it for a security system, because they said they're away from this particular home for periods of time, and they'll watch it, and if they see the consumption go up, they're like, the door's open, or a window's broken, or someone's in there. Which I thought, that's interesting, I never thought about that.
My heat is pouring out that window.
Yeah, better run up and check it out or whatever. But.
Yeah. So this is really, what we have kind of, said is really one of the best benefits is in order, anytime you can put it back in the hands of your consumers and your customers, help them manage day to day, the cost that, of electricity, that's really a huge benefit. So, yeah.
I think Rocky Mountain Power has part of the DSM, their energy report.
Yeah.
Is that going to be coordinated with this, or is this going to have you thought about what you're going to do?
I'm sure if they,
As far as I know, they.
hopefully eventually, because I know, I just got that the
Yeah.
other day, and it's like, oh, this is how much I'm using
Yeah.
they estimate by lighting and all of that. I'm like, how do they know that? They don't know that.
Even like a link or something that says, here's how much you're using, if you wanna see a more detailed, click on this and it'll take you to
It'd still just be, I don't know if that then can break down, like on this day, this is what we estimate this is the typical kind of appliance usage that is occurring at that time, or something like that, maybe
Yeah.
eventually, but.
Yeah, that's it. I'll take that back though.
Yeah,
Because we
I
really
understand,
haven't, again, just moving into this and kind of we've got a lot we're looking through for Utah. We've got to work back individually on what they have versus what we have, because we certainly wouldn't want to present any type of conflicting information to them.
We don't want
or-
that to make anybody think that we do know what's going
Right.
on within their home.
Right, which is definitely, what we have seen from customers in Oregon. There's a lot of perception out there and a lot of information that is inaccurate on the internet about smart meters.
Shocking.
Shocking. I mean, it's actually a little shocking, actually, some of the bad information. And we're countering that in Oregon, and we're really happy to, and that's like one of the reasons the workshop started, is because we had to get in front of these communities and try to start counteracting some of the really bad information, absolutely false information that customers were being given. And I have had customers who've literally written me letters who firmly believe that I absolutely know what is going on in their house. I had a gentleman at a workshop literally tell me, you know what's going on in my bedroom, and I said, No, I don't.
Please don't tell me.
Please don't tell me. I mean, he was convinced of this, and you know, I kind of, you know, half-heartedly said to him, you know, I'm installing like 600,000 meters in Oregon. How many people would it take for me to put in a building to sit and watch every customer as to what you do every single day? And he kind of looked at me, and I go, really? I mean, how many people would it take? I mean, and he's like, yeah, I guess you might be right. I'm like, you know, we don't have the time. Not that I don't care what you do, you know, but, you know, and we kind of had a chuckle because I think it was just, he had heard this reiterated so many times. And he was like, you know, until we kind of had this like heart-to-heart conversation, it was like the realization of, oh, kind of that sounds ridiculous. So it's just, you know, that's definitely been a concern that customers have. And we've definitely strayed away from ever trying to be about, you know, we know which appliance you're using. So we try to basically say to them, let's look at your usage. What could be going on in your house that makes this spike at, you know, at a time where you say you're not home? Do you have a heater that's plugged into your wall that's got like an automatic dial set on it so it hits a, you know, a cool point and then it turns on? Because those automatic heaters consume a tremendous amount of electricity. So, and in the winter months, which is usually our higher months that we get a lot of calls about high bills, this right here has been, you know, very helpful for our agents, for customers to really kind of pinpoint, you know, what's going on. So definitely with the ability to roll this out to AMR, huge benefit, and we're definitely going to capitalize on that.
Did you have an uptick in the number of people who wanted to opt out in Oregon?
In Oregon?
Yeah.
We are trending about what we had projected, which was that we projected about a 1% opt-out, and we are right now kind of trending along that. I will tell you, as we've rolled out, you know, we've had people who've opted out. I probably get 20 plus opt-ins a day. Once they start getting charged the fee, or we've, you know, met with them in workshops and they start, you know, educating themselves a little bit more than just the, you know, the world is gonna come to an end if you have that. They actually start, you know, a lot of them are just fear. It's fear, and they target an older generation. I hate to say it. And, you know, they get really afraid. They think that their pacemaker is gonna go off, that we're gonna kill them. And so, you know, you sit down with them, whether it's our call center or whether it's us in the workshops, and just, you know, have an honest conversation, and we're kind to them, and we just try really hard, and we've actually been able to get some of those people kind of talked off that ledge, and we've got people that are opting in, and I'm watching those numbers, and they're actually in many communities starting to trend down where people are, you know, realizing that.
95% of the 1% is in two communities
Yes.
that we serve, in Medford and Grants Pass, Oregon. And let me add there's a third piece, and that's a couple of towns in California. So they're geographically pretty close to one another.
Kind of a cluster effect of.
There's a cluster effect, and
Pure
yeah.
pods.
What's that?
Pure pods.
Yeah, I won't drag it in anymore. I won't give any more comments on that, but I'll just say that, you know,
So
5,000 opt-outs, 4,000, some of them are in those three areas. So
We've developed some real friends with some of the.
we have a following.
We have a following. We definitely have a following.
So you said that you're not interested in telling customers what assumed appliances are operating at any given time. Is there any way you could opt into that type of information?
Well, I don't know that we said we weren't interested in that. It's just that we're not ready for that.
We're not ready for that.
Oh, okay.
Yeah.
And then doing
Yeah.
that will be just a little bit more delicate and making
Yeah.
sure that they know that
Yeah.
we're not actually seeing that
Right.
you're watching TV.
Right, you're assuming based on the patterns.
Yeah.
Yes. Yeah.
Is there any?
And what channel am I
There is technology I know out there, because
Somebody
we have a
knows
sister
that.
company, NB Energy, who is looking at further that type of information further. And when they talk to us, my first response was, oh, hey, not right now. Let's get this out, you know, because we already have that concern of, you know, you're watching to see everything what I do. And while I do not, you know, disparage that new technology that's coming out that helps people manage that use, I mean, they think it's great, but for that customer base in Oregon right now, for us, it was, we need to just focus on the benefits of helping them control their usage, making it really, you know, them taking control more than us telling them. And so that is just a strategy that we have used and we've kind of stuck with for this moment.
Is there any plan to roll out an app?
We have an app.
Okay.
We have an app.
So you said that you're not interested in telling customers what assumed appliances are operating at any given time. Is there any way you could opt into that type of information?
We We actually do
For
have
this
an app, and
information.
this information is on the app, yes.
So you can report an outage, you can
Yes.
see what neighbors were out, you can,
Yes, we have
See
we have an outage map on our app.
We
have
apparently need
almost
to
all
do
the
better
functionality.
communications on our app.
Yeah, we actually have, we
Oh.
do. Actually, we have, all of this functionality exists on our app right now.
Cool.
Yeah, so I encourage you to download our app.
John's been wanting to ask a question.
Well, Joseph hit some of what I
Oh.
was at, but I'm just encouraging you to chat with your DSM folks, because I think your messaging, at least here in Utah, might be inconsistent. Because they have, at least they've had presentations in some of our meetings where they've talked about providing people with estimates of which appliances are running and things like that, so.
And they
so I'm-
do that.
Yeah, so I'm just saying, if, it just sounds like you have very different messaging there. I'm not saying there's a problem with there, I'm just saying you may want to spend a bit of time thinking about chatting with them and if there's any areas you need to fine tune.
Yeah, because that messaging could become more granular with this
Mm-hmm.
information.
Oh, well, absolutely, I mean,
Yeah.
if you give hourly interval data to some of the things they're already doing, it would make theirs more precise, but.
Yeah, except it's still an
Now it's a
estimate.
3-month is what we get from them.
Yeah.
I mean, it's.
And but it's
It's
still what's
probably
what's
your-
the typical appliance?
Yeah,
and,
yeah.
And, yeah, I'm just saying you may want to think about the message in itself. I'm not saying what's right or wrong. I'm just saying you may want to
Yeah.
think
It's a
about
good-
coordinating a little bit more.
It's a good-
And the great thing about that is our corporate communications group works with that DSM group, and so they are, they basically manage the messaging for DSM and for us, and so thank you, I will make sure that our groups, pull together that DSM messaging, and so we're not going in any separate ways.
And I
Appreciate
mean,
that.
we really hope that and expect that this will leverage all sorts of new ideas and opportunities as we kind of get through that initial, just getting them installed.
Yeah, we have a while.
Yeah, a little bit. You'll be around still.
You might be lucky, you might have 50 meters.
Let me ask one more question. So, just a thought. So we're talking about the benefits of doing this, rolling out AMI, but one of the things we're doing is the AMR reading functionality, right? You can install antennas to collect that information.
We want to.
You want to, right. So currently Dominion is rolling out Itron AMR meters. You guys consider talking with them about a partnership to split some of these costs and maybe charge them?
So the answer to that is yes. We had conversations back when we rolled out the initial AMR. They had opted at that time when they were requesting our gas to go with a different technology. So, yeah, with them rolling out the Itron AMR,
It might be an opportunity to.
there's an
add
opportunity to
benefits.
that, yeah. So, yeah, we've actually looked at what are the other things we can do. I mean, when you start to build this network out, let's take Murray City, for example, here in the middle of the valley. I mean, we serve, about a third of their customers already. And then the network will be penetrating in just because of the wave propagation, will be penetrating in their city. They have Itron AMR meters. So the question goes, well, can we help Murray City out with their cost? And then we just have to put a few devices in to fill just the center of the hole where we can't quite get to.
I know a lot of the water meters as well. It sounds like when you complete replacing the AMR meters, you're gonna have infrastructure that's no longer needed, so it seems like you could continue to benefit by collecting information for the utilities.
Yeah, I think there's a huge benefit there to help them and lower their costs, to help us, help lower our costs as well. I think there's some great synergies out there if we can pull it off. But what's interesting, the few conversations we've had, we're about 2 years too late for the water companies for most of them. Because talking to a few of them that I've seen, about 5 years ago, they all started going to automated reads. And they're putting in a whole different technology that we can't even listen to.
Oh, they're not Itron.
No, a lot of them put in what they call Badger, or what was the other one? Water Tree, I think it's called. There's lots of, I mean, across the nation, there's just north of 200 electric utilities, and there's over 4,000 water utilities. So the technology for meter reading for water meters actually was far in advance of electric, because for them to read a meter was a lot harder. I mean, they didn't just walk by, they had to stop, pull off the pit cover, in some cases get inside the house, because the meter's inside the house, I mean, their costs were way up there versus ours, so. But yeah, it's actually something we are considering looking at, and we will have those conversations. We don't wanna do it until we get the system ready to go though, because if they want it next week, they can't do it.
I have one more.
We can pay some development costs too, though.
Yeah.
I have one more question about, you mentioned Verizon would probably haul from the head to the company. Will the AMI infrastructure be compatible with 5G technology? Did they roll that out? Okay.
Down to Autumn.
Really
Yeah.
quick, I just have a couple of things.
2G technology right now.
So, a couple of things we're gonna look at as far as tariff changes. We currently do have an opt-out option for our customers for the AMR. We're certainly gonna review that to make sure it aligns with AMI customers that choose to opt out. And piggybacking on what Allison had said, we're looking to propose maybe a modification to how we do collection notification. The past due notice, final notice will stay the same, but we're looking at maybe changing the way we deliver 48-hour notices. Certainly though, with any change, will be communicated to our customers. We know that's certainly a key thing. And same with the opt-out. Certainly, there are going to be customers that really choose to not have a smart meter. So we want to be able to have options for our customers for that reason.
Although I will note, Idaho does not allow an opt-out for AMI. It's not that you don't have to pay, it's like they do not allow a customer to opt out.
And then just tagging on to that, as far as the communication strategy, we're definitely gonna work to finalize that, and, we'll be back, of course, to, talk to you guys about whatever it is we, finalize and come up with. But we definitely need to work through the messaging because of the different demographic, meter demographic, you might say, and, so we'll come back with that, but we'll definitely most likely follow along kind of some of the same lines that we utilized in Oregon, but just making sure that we're very clear and concise to each customer base so that they know what is going on, what they're doing, so that there's not confusion. But we'll definitely promote out definitely the benefits, of course, and going back to that strategy, creating awareness, big picture, and what the benefits are.
I think when we talk about the interval data and that, all of our, if we do the PERT gateways, all of our residential customers will have the interval data. There are some of the small C&I customers today that we have an AMR meter on them, but because of the demand component in their metering, we will not be doing interval data with the existing meters. Because what we do with those meters in the commercial industrial is once a month we do what we call a self-read and reset. So the meter takes the current readings, stores them off in a register, and that's what gets pulsed out. And so I'm gonna get the exact same reading for the next 31 days until the next self-read and reset, so that's all we're gonna see. So the small C&I customers, we're not gonna be able to do that. But again, as we start changing meters out, we'll get them to that level. And we still have the energy profiler online option for them if they wanna go to that. If they wanna go to that, we'll probably just say, no, we're not doing EPO, we'll change out the meter at a small cost for those guys if they wanna go to it. There's an interest. So not 100% coverage on interval data, just to be aware.
Anything else?
When do you anticipate the step filing on this?
We're saying first quarter, that's how big we are about it.
First quarter-ish.
Oh.
We're in the first quarter.
And speaking of workshops, I was gonna just offer with other staff, we have certainly brought the meters in for you to get a hands-on look and kind of demo everything, so if that's something you're interested in, we'd be more than happy to do that as well.
Meters and collection devices, whatever you want.
We'll even put one on your house at the right time if you want.
There you go.
Well, thank you all for coming.
Thank you.